Hi everyone, today we are still on chapter 19 of your textbook and we're going to look at chromatography. Before we start, I want to pose a question to you. If I mix blue ink and yellow ink together, what does it make? Hopefully you know that it would make green. So blue and yellow mixed together will make green. But if I gave you a green marker and asked you to prove it, what would you do? So I'm giving you a green marker. You have no access to blue and yellow markers or ink or anything like that. So you can't prove it by mixing them together. You need to just use the green marker to prove it to me. What would you do? Maybe some of you know the answer already. Maybe some of you don't. But today we're all going to learn about how you would do it. So the technique is called chromatography. It's from Greek, and chroma means color and graphy means writing. So it means color writing. And this is the definition for it. It's quite long, so we're going to separate it out into the three sections that I've underlined in different colors, and we're going to talk through it together. So the orange bit. Paper chromatography is a method of separating mixtures of substances in a solution. So that's not too bad. That's separating a mixture into the different substances that make up the mixture. And we're separating them based on their colour for chromatography. The second part is in blue. The solvent in which the substances are dissolved is passed along a length of paper. So the mixture that we're studying is placed on a piece of paper which is dipped into a small amount of solvent. And if you remember from your homework a couple of weeks ago, a solvent is a substance that can dissolve other substances. So we're placing the piece of paper that our mixture is on into a small piece of solvent. And then in purple it says, and the dissolved substances separate out on the paper. So as the solvent is absorbed by the paper and travels up the paper, so does the ink, and that allows us to separate out the individual substances that were making up the mixture. Let's go through that again, but this time with a diagram to help us out. So we have got a dot of sample is placed on a piece of paper. So we've got our dot of the sample here down at the bottom. The paper is placed into a small amount of a suitable solvent. So our solvent is down here at the bottom, and you can see we only have a small amount of it. The solvent that you choose is very important because you need to make sure that the dye will dissolve in it, or the ink will dissolve in it. So you need to choose a solvent based on that. And it's important as well that we only have a very small amount of it, because if we filled our solvent up to here, the ink sample that we have would be under the water. And so what's going to happen then? The sample, the dye, is just going to spread out into the water. It's not going to travel up the paper at all. It's going to spread into the water. So it's important that we only use a very small amount there. As the paper absorbs the solvent, so as the paper soaks up the liquid from the bottom, the ink will be dissolved too. So as the level of the solvent rises, from down here, let's say, as the level of the solvent rises, it's going to dissolve the ink or the sample, and it's going to carry that with it. And what happens then is the ink will be separated out into the different colors that make it up. So this one is made up of yellow, pink, and blue. And then at the end, when we take that piece of paper out, we don't call it a piece of paper anymore. We call it a chromatogram. So it's the strip of paper on which the parts of the mixture have been separated. So it's basically a piece of paper that has a mixture separated out on it. So now you're going to get into this and do the experiment yourself. So usually we would do this in class, but you're going to try to do it at home. Before you start, I want you to know that you're not using the proper materials that we would have in the science lab, so your experiment results might not turn out perfectly, but that is absolutely okay. It's about your effort and about you understanding the steps. So I want to see you doing the steps, and I want to see your results even if it doesn't look that great at the end, because in fact my results didn't turn out great. So it's about going through the scientific steps and understanding the process, and if it turns out perfect, then that's great, but it might not, and that's okay too. So first of all, just to prove to you that it's okay if it doesn't work out, I'm going to show you my results so that you can think about that as we're going through the experiment, and you might be able to make your experiment better than mine. So here are my results, and if you compare this to the results we saw before that looked perfect on the picture, you can see that mine isn't perfect. The colours didn't travel very far up the cardboard that I'm using instead of paper, so you couldn't really see the different colours in the ink. And also I used some cardboard from toilet roll for this, because normal paper doesn't seem to work very well. You need a special type of paper for it. So the join in the toilet roll that you can kind of see, because they're rounded, that you can see that line along there that I've drawn on. That made my red colour, if I get rid of it again, that made my red colour go kind of sideways. So if you can think of something else that might work better than toilet roll, absolutely give it a go. You don't have to follow these instructions perfectly. If you can find another experiment online that you want to do that's on chromatography as well, or if you want to change some things about it, feel free to make the experiment your own. The second last bullet point over here on the right is saying that if anyone in your house makes filter coffee, you could ask them for some filter paper, because that's very similar to what we would use in school. So what you'll need for doing it my way, again, you can change the toilet roll to anything else that might work. You might test out a few things first. So this is everything you need. The pens or markers that you use, I would recommend that one of them would be black, because as you might already know, black is a mixture of all the colours, so that tends to be the one that gives the best or the coolest results. You can't use whiteboard markers or permanent markers for this. They usually don't dissolve in water. So step 1 is cut your toilet roll into a strip that's narrow enough to fit inside whatever glass or jar or cup that you're using. Using the pencil and ruler, draw a horizontal line across the bottom of the toilet roll, approximately 1 centimetre from the bottom. And it's very important to note here that we're using it lengthways, so you want it to be as long as possible. Step 3 is going to be putting your dots on. I'm not going to read through absolutely everything here, because I'm going to put this on Teams for you and you can download it and go through the steps yourself, but I want to go through it just briefly with you. So mark out for step 3 the dots where you're going to put your dots with a pencil. That will mean that you'll be able to know at the end where your ink began. Next, draw on your ink spots, and I've just some information for you there that with a pen you'll need to go over it a couple of times, but don't rip the cardboard. For a marker, dab it on the same spot a couple of times, but don't just hold it down, because the ink will start to spread out. Next, you're going to stick your piece of cardboard or whatever you decide to use yourself onto a pencil. So you've got your pencil over here, because I didn't have a glass rod at home. You've got, mine was toilet roll hanging off of it to make the T shape, and I just put a little bit of sellotape on it at the back to keep the cardboard in place so that it didn't fall into the water. Step 6 is to make sure that you're checking very carefully how far down your glass or cup or jar that you're using, how far down the cardboard reaches. Because remember, we only want to add enough water so that it touches the bottom of the cardboard. We don't want it to reach this ink spot. We want it to be well below that. So next, add the water to your glass or your jar. Check the height again to make sure that you're not putting too much water in, and then slowly put your piece of cardboard in and make sure that you're checking again. Remember, it's really important that the ink doesn't go into the water. That's why we've put the dots on at least 1 centimetre up the piece of cardboard. Step 8 is place the cardboard into the solvent, and I've written in small little writing there, do I need to remind you not to let the ink touch the water? Just be very careful with that, otherwise your experiment definitely won't work. And let it stay there until the water is soaked up along the cardboard and that it gets quite high up the cardboard. You can see I didn't let mine go all the way to the top because I could see that the ink had stopped traveling, and it's okay if that happens. I mean, a lot of the pens and stuff that we have aren't going to be great for this, so it's just a case of going through the steps and trying it out. Step 9 is remove your chromatogram from the solvent and let it dry. Do you remember what a chromatogram is? It's just the sheet of paper, the piece of cardboard that has the mixture separated out on it. Again, as you saw earlier, my results didn't work perfectly. Hopefully you guys will think of maybe a couple of ingenious tricks that I didn't think of, and you might get it to work better for you. But even if it doesn't, that's okay. I still want to see your results and I want to see that you've tried. So our conclusion here, even though my results don't show it, but you can see pictures of it in the book on page 178, the conclusion, what the results tell us, is that chromatography can be used to separate the dyes in a sample of ink.